Let us take a look of the last topic I want to introduce you before the exam number 2. This is about working with tables. How do we manage the data inside of the database? In the previous class, we talked about how do we create a structure of the data. We basically develop multiple tables, forming the foreign key, constraints, primary keys, everything. So we have a space to store our data. Now let us learn how do we insert, update, and delete the data inside of the database. These are the topics that we have discussed similarly to the previous topics, like when we try to insert the items, when we try to update, when we try to delete the items in theory. And now it is time for us to see how can we really implement these operations in Oracle. So insert is add a new row into the table. Update indicating we want to change some information that already existing in the table. Delete means that we can remove items from the table. You may notice that when I focus on updating, data is in existing rows are changed with the update statement. That means it is possible for us to change one row at a time as well as multiple rows at the same time. Same thing about the delete. Remember that we have these problems before. We can delete multiple items at the same time, and therefore it's the same thing. We can delete one row at a time by providing a very specific primary key, and we can delete multiple rows at the same time if we don't pay attention. And therefore these are the important things that we want to look into in this topic. So starting with the insert. The data manipulation language DML statement insert is used to insert a new row or new records or new tuples into a table. And therefore, here is the general syntax for us to do that. When we want to do the insert, the reserved word is insert into. So when Oracle sees the word insert into, it will understand that you want to do some insert operation. The next thing that you need to provide is going to be the table name. So which table that you want to insert the things into. Then there are optional operations by providing the column names one by one. If you already know the order of the table, then you don't need to provide these columns. Then reserved word again, values, indicating that these are the values. I want to start inputting the values for each attribute. So now try to catch it. You will have an open parenthesis, close parenthesis, and a semicolon to indicating this is the end of one insert operation. Inside of a parenthesis, you try to provide all the column values one by one. Therefore, let us take a look of the example directly. You see that this is a code for us to insert a new employee, John Smith. So you see, we will start with the insert into and then provide the table name. Employee is the table name. So Oracle will know now I want to insert something into the employee table. The values indicating the value one by one, every single value according to the order provided by the creation of the table, which we will input all the values over there. Open parenthesis, close parenthesis, and a semicolon indicating that this is one code that we want to do the insert operation. Also, you may notice that there are some words has been quoted, some words are not quoted. First of all, Oracle use single quote, so double quote do not work. Next, if it is a data type of CHAR as well as the varchar 2, they all need to be quoted. So you can see John Blacksmith, they need to be quoted. If they are numbers, they don't need to be quoted. This is the format for the date input. And you see it will start with the day and a 3-letter month, and then the year with 4 letters. This is the default format for Oracle to take the date. And of course, one more detail is that it is quoted as well. And therefore, these are the things that we will be able to see for us to insert a new employee. The similar things, if we want to insert into department, we have values and research department, department number 5, this is a number, and then social security number, and then we will have the date of the starting date for the manager. And therefore, these are the 2 examples you will be able to see. Of course, both examples do not appear those optional code, column 1, 2, and 3, because it simply follow the order of the table creation for each attribute. The column names are optional, as I mentioned. If column names are omitted from the insert statement, you must enter a value for each column. And of course, if you know the order of the columns in the correct order, you can enter the values in the same order, follow the value keyword, which is what we did for the 2 examples. Of course, you may ask, okay, how do I know the order of the attributes? Basically, we already learned that. We can describe the table and you will show all of the attributes in the order it has been defined. If you don't enter the column name, if you do enter the column names, they do not have to be the same order. So you can create your own order by providing one by one and then mapping the values for each attribute that you have showed. And therefore, you can see that this example is an insert into a student, and then we provide a student ID. Therefore, the first value you're going to put into the values is going to be the student ID. Last name, first name, you will follow the order that you provided in the program. So when entering values, numeric data is not enclosed with quote. The character of the data type values are enclosed in a single quote. Again, single quote. Double quote does not work in Oracle. The default format to enter the date is day, 3-letter month, and the year. So there are 2 methods to insert a null value. Sometimes we may have null values. So how do we put a null value? There are 2 different ways. The first way is the implicit method. The second way is the direct method. So for implicit method, let's take a look at this code. In the implicit method, the column name is omitted from the column list in the insert statement. For example, department has 4 attributes. It has department ID, department name, manager, and manager start date. So what if I have a new department that have not decided who is going to be the manager yet? Take a look at this code. What this code trying to do in an implicit way is that it provides 2 attributes, department ID, department name, intentionally avoid manager and manager start date, and you provide 50 is the department ID, production is the department name, and of course the rest 2 attributes will get the null value. And of course that means the 2 attributes are not bounded by not null constraint. In this case, we have successfully put null values to the manager and manager start dates attribute. An explicit method, of course, is that you simply put a null value over there. So that in our previous example, we can say insert into department and put 50 into department ID, production into department name, null, and null for the rest 2 attributes, like what we have seen in a previous example. In this example, it's going to be the same thing, department ID, department name, so it's a slightly different design with our company database, but it doesn't matter. You can see that employee ID over here is actually getting a null value explicitly, and therefore, this is how we can do null values in our database. And therefore, now, since you already understand the whole pictures, while we're looking into the relational schema diagram, we actually will see one problem that you may have not considered yet. Let's take a look at this. You can see that when we create the relational schema diagram, we need to define tables one by one. And after all the tables are defined, we try to define the foreign keys by alter table. In this case, saying that we have created whole structures. Now, while I'm trying to insert the employee, the first employee, I will put in all of these informations until you will see one problem, DNO, indicating that which department it works to. If this is your very first insert operation, which means that all other tables are null, and you try to insert the very first employee into the database, you will realize you actually get an error message. Why is that? Because you putting an employee, say, work for department number 5. And since every other tables are null at this stage, there is no department number 5. And therefore, when you try to insert an employee who works for department number 5, it is not going to work. And that is actually a problem. Because if we try to insert the very first department, saying that department number 5, it's possible that you're putting a null values over there to make it work. And you can understand that when we're trying to do that, it's actually a lot of troubles, because you can put null values for manager, SSN, manager start date, so that you can insert one tuple. But after all the operations, you need to remember insert those manager, social security number, manager start date back to the department. It's actually not very straightforward. And therefore, here is the small trick I want to show you for developing what we call the initial state of the database. And this is the code that I have included in the class for you guys. So you can take a look at this one. This is the code that recreates the whole company database. So first of all, it tries to drop all the tables that has been created earlier. Then it tries to create the employee table. It then creates the department table, department locations, project, works on, dependent. Originally, after all the tables are created, we are supposed to use the alter table to add the foreign key back over here. However, because this is our initial status of the database, instead of adding the foreign keys, we try to insert all of the initial informations that we have. Because the foreign keys are not defined yet, so there is no problems for us to insert all of this information. And therefore, we can keep inserting everything while we have all the data are input. Then we add the foreign keys back. So this is a small trick. You can see that these are the foreign keys that we have been added back to the database, and therefore we would be able to have the whole initial status. And so that you can see the whole program is divided into 4 parts. The first part is about dropping table, because we try to reuse this code so that we can create an initial status of the database. Then we try to do all the create table part, so we create all the tables. And then we insert all the data into the database, and finally we add the foreign key back over there, so that we would be able to recreate the whole database in the database that we discussed in our class. And therefore, you will be able to have the whole data like this in your Oracle. I include the code into today's class, and therefore what I want you guys to do is simply execute the code and try to get the whole database in your Oracle database, and so that we would be able to learn how to do the queries for the third part of the semester. Finally, you may have a question saying that, okay, say we have successfully run the program, how do I know the data is really there? And this is the command I want to teach you guys to do the most basic query of each table. So when we're trying to see the table inside of that, what we can do is we can do select, indicating I want to see the information. Star means I want to see all information from a table that you are interested in. And therefore, if you do select star from employee, what it will do is that it will show you all 8 employees with all of the attributes. This is something I want you guys to try and take a look. And not only take a look at the employee table, but also works on table, department table, project table, dependence table. It takes no time for you to see those information. And that is the first part of the Oracle DML code for the insert operation.